Good morning, everyone. Welcome to this webinar, which is introducing Climb Forest. You can take the next slide. Yes, my name is Adam Christensson. I'm coordinating the project Climb Forest. And you can take the next slide, James. And what is the Climb Forest project about? Well, we are proposing alternative pathways for the entire European forestry, for forest management and tree species. And there are different ways that we can go in the forestry, depending on which geographic regions we are in. Next slide, please. And what we do at the same time, what are our goals? Next slide, please. Yes, so the forest should provide capacity to mitigate climate and be resilient towards climate change. And it should preserve biodiversity and ecosystem services at the same time. Both on for the climate, for example, it's important to remember that it should cope with climate on short term, but also on a very long time scales. Next slide, please. And the foundation of Climb Forest is the work we do with measurement data over entire Europe in different field sites and with satellite data. And we do also process modeling of the things taking place in the forest, of all the processes. And finally, we do also European scale modeling of vegetation and how different actors behave in this whole system with the forestry and global trade and so on. And a unique thing in Climb Forest is that we try to take a holistic view on all the climate effects that are taking place in the forest, and not only the effect that we have the forest is taking up carbon dioxide via the photosynthesis. Next slide, please. And another question we ask ourselves, how can we do to store more of the wood in long-lived wood products? So we try to find different ways that use the wood for furniture, building material, and that it should be in a circular economy, that it could be renewed. So that's another goal of the project. And please, next slide. And all of these things are done together with the forestry stakeholders, which come from different branches, which have different interests. And here we can see already some pictures of 2 forest field visits that we have had already, where we try to discuss with the different stakeholders what kind of forest management options are possible in different forest regions, like in Spain and Norway in these examples. And that's how we would like to work, that we do nothing without our stakeholders. Yes, please, next slide. And that was the introduction into Climb Forest. And if you have questions, please leave some comments or questions in the chat function. And hereby I welcome you again to the project, and also to the next, I present also the next speaker, Anders Ahlström and Paloma Ruiz Benito, who will tell more about our project in a few seconds. Thank you very much.
Okay. Hello, everyone. I'm going to talk about Work Package 1, or part of the project. Can we move on to the next slide, please? Okay, so basically, we're just going to present quickly the main questions and some of the things we're doing in parts of the project. And we have formulated this as 2 key questions that we're trying to answer. So the first one is, what is the state and changes of primary forest in Europe, and how do they differ from managed secondary forest? And primary forests here are largely unmanaged or largely unaffected forests by modern forestry, and likely or hopefully also that they have seen limited impacts in the past from direct human impact. And the second one, what is the current status of secondary forest in Europe, their stand, age, and composition? So next slide, please. So about the first one, about primary forest, they can be used as a baseline for states and changes in forests with no direct human impact. So basically they represent the natural processes and the natural states in terms of the amount of trees, their size, soil carbon, and deadwood, and so on. And by comparing them to managed forest, we can get a picture of sort of the impact of management over a long time. So these graphs just show two hypotheses and how they can be used. So in the first one, we're seeing a primary forest in equilibrium with the environment that is not really changing, and perhaps an upward trend, so a carbon sink in managed forest. And in the second figure is another hypothesis or another illustration, basically showing that both ecosystem types are perhaps changing over time, and that the managed forest may then still be different from the primary forest. It could have more carbon and perhaps a larger trend, or less carbon and a lower kind of uptake trend. And this is then on the y-axis carbon storage, for example. So an upward trend would be an uptake of carbon. Next slide, please. So basically what we're doing first here, because we know so very little about primary forest, their location and their state. So what we're doing first in this project is looking at carbon storage in the forest and basically asking, is there more or less in this primary forest than there is in secondary forest? So you can move on, James. This will not tell us about the slope of these curves. It means it will not tell us anything about the uptake over time, but it will tell us about the states, which we think is one of the key kind of missing information we have about this forest. So next slide. So what we do, this is an example from Sweden in this work package, is that we basically map the forests, which we have done in Sweden, and we're doing it in other parts of Europe. And then we do a paired analysis. We basically compare, we go and visit, we do field inventories in this primary forest, and we compare to secondary forest around them. So this mapping and inventories is a key aspect in the project. And these are sort of the kind of results that we expect to have. So on the left graph, we have carbon storage in vegetation in primary forest on the x-axis and secondary forest in the y-axis. So in this case, we see 1-to-1 line, and then we have a 2-to-1 line and a 4-to-1 line. So in this case, we can see that these primary forests store about 2 to 4 times more carbon in vegetation than the secondary forests that are growing in the same kind of region do. In the second one is another example that we look at drought impacts. So we look at satellites, and we can use that too. So once we have these maps, we can extract data. And in this case, we're looking at the dry spell in 2018, also only for Sweden. And we compare again the forest in these pairs. And what this figure then show, for example, is that soil moisture is very important. So the topography. So we have soil moisture class 5 is the most moist, where we can even see a green up during dry conditions because there's enough water and so on, and perhaps also the evaporation cools the atmosphere. And then when we move to dry classes, we see larger and larger impact. This is not very surprising. But what we also see here then is that, for example, the impacts of these primary forest or in the primary forest during the dry spell was overall smaller than it was in the secondary forest. Yes, so I'm going to hand over to Paloma now.
Okay, we will work with National Forest Inventory data. This information has been already gathered in previous projects as the tree mode and the 4MMI. As you can see, we have quite a wide and broad latitudinal gradient across the entire Europe of data. And we have obtained in this project some more countries as Ireland and others only with one inventory, as for example, Italy. We have data at tree, plot, and grid level, and it's true that the sampling protocol and the time between inventories varies, but we are already getting some further information, as in the next slide, where you can observe from this previous project of Susan Subanto how harvesting intensity, the frequency and the mean intensity has been calculated across entire Europe using 11 countries. If you continue passing the information, the goal from this information is to generate a pan-European map that will be further used in the modeling part of the project, and we will also be used to better understand empirical relationship, as I will show later on, between management, carbon storage and biodiversity. The second pan-European map that we are planning to do is about the stand age, as we can see in the next slide. And we are, as a first step, Julian is going very deep into the National Forest Inventory data to see how reliable is the information about the stand age in the different forest inventories. This is some of the countries we have been already looking into the information, and we will combine this also with other field information data to see if we are able to generate this pan-European map to be further used in the modeling working group. So with the National Forest Inventories, as we can observe in the next slide, we are updating data about biomass across the entire European gradient. This is a map from the first harmonization some of the people in this working package were involved in, as Miguel and myself. And with this data, we can calculate very precise information about the stand structure and diversity, and we are planning to use this data to calculate how carbon and diversity might change depending on management and climate in the project. And to finish, we are starting to have, if you can go a little bit on, yes, like that, thank you, James. We are starting to have some very in-depth discussions because we are also very interested in understanding how management might interact with climate, forest structure and diversity, leading to differential demographic rates for the many species in Europe and changes in composition and biomass. So we are starting to do some empirical analysis here. And thinking how theoretical we can include this in this theoretical model. So this is basically what we are doing in this first part at the European level. And yes, and I give the word to the next speaker. Thank you.
Yeah, thank you. So this part of the project compiles the empirical basis for the interplay between forest management and ecosystem processes. And here we focus in particular on those related to biodiversity, climate change, and in particular climate extremes and also disturbances. Next slide, please. We are using measurements from long-term monitoring sites, where the ones where fluxes of carbon and nitrogen and their stocks and also energy fluxes are measured continuously. They are of particular importance, and these are called the so-called flux tower sites. You see one example of a flux tower on this slide here. And among the flux tower sites on networks, the integrated carbon observation system, ICOS and FluxNet are particularly worth mentioning. And then we also scale up these local observations using remote sensing. Our attention is towards the impact, in particular the feedback between forest management and disturbances like climate extremes, fire or pathogenic attacks on carbon and nitrogen stocks and fluxes, on biodiversity and on biophysical properties like, for example, the forest structure and the local or microclimates within a canopy, but also the chemical composition of near ground air and soil properties. Next slide, please. Concerning the biophysical situation of forests, we investigated the relation between forest structure, forest function, and the forest resilience, which is the ability to recover from disturbances, so recovering capacity. Forest structure is the quantitative concept in the project related to age, tree diameter, tree heights, vegetation indices, phenological status, tree species composition, diversity indices, habitat diversity, and so on. And with function, we refer to the microclimate within the forest, for example, the cooling effect of a canopy, the carbon and energy fluxes, light use efficiency, water use efficiency, and the response to extreme events like heat and/or droughts in combination or fire. And these properties are partially determined by site conditions like water availability, soil characteristics, elevation, and other variables. And we look at special situations like the occurrence of climate extremes, such as southern heats, years like masting years for some tree stands, or legacy effects of former events like, for example, storms or also management interferences. Next slide, please. One example of these legacy effects is an experimental study conducted by our colleagues in Spain, where a site exposed to a fire a long time ago is investigated and measured for soil properties and others, and also an artificial drought experiment by rainfall exclusion. Other manipulation studies are also part of the project in different countries. Next slide, please. So the overall goal of this part of Climate Forest is to identify all, in quotation marks, climate effects and relevant processes. This is exactly what Adam mentioned already in the introduction. I brought this slide from another project partner, Jana Beck from the University of Helsinki. Besides the processes and fluxes already mentioned, like that of carbon, methane, nitrous oxides, heat and energy fluxes, the basic photosynthesis processes, and so on, we also focus on the creation of some larger molecules, like the biogenic volatile organic compounds, or BVOCs, and aerosols. They are summarized as the short-lived climate forces, SLCF. They have huge climate impact factors of several hundreds to thousands, where the carbon dioxide molecule has a factor of 1. On the other hand, their concentrations are usually small. They are also in part produced by the trees themselves, in part impacted on them externally. And the net cooling or warming effect is unclear at this moment. So therefore, they attain a special role in climate forest and will be further investigated. And with that, I hand over to Lisbeth Franken.
Okay, so in this project, we also look at how forest management can contribute to a sustainable bioeconomy and what role wood products can play in that. Next slide, please. Okay, so for that we focus on a few activities. So the first one is to map current and future trends in demand for wood and wood-based products and associated needs in wood properties. Next slide, please. So we want to make sure that, okay, if you look at or propose forest management scenarios that help to mitigate climate change, that they also meet societal needs, that they are community supported. So therefore, we map those trends in the demand for wood. We'll do that, and we're currently working on that with a systematic literature review and with some stakeholders interaction. So we actively have some interviews with different actors in the wood supply chain. Next slide, please. Okay, the next step we look at the demand for wood products, especially long-lived wood products, as they capture carbon. But then we want to investigate, to what extent those are environmentally, those long-lived wood products, superior to other products that they substitute. For that, we rely on life cycle analysis and life cycle costing. Of course, we cannot do that for all wood-based products, so we'll make a selection. For that selection, on the one hand, we'll base ourselves on a systematic literature review that will learn us, for which wood products are in high demand, what the market shares are. And then we'll consider also carbon emission intensities and product lifetime and recyclability when assessing the environmental impact of some wood products and the products they are substituting. Next slide, please. Okay, so then we know to what extent certain wood products are superior or not compared to their substitutes. On the other hand, we also want to, even if they are better, we want to make sure that the alternatives we propose and the wood products they deliver, that those wood products are also preferred and demanded and bought by consumers. So therefore, we will assess consumer preferences for selection of wood products. Again, it's not possible for all wood products. For that, we will rely on a choice experiment, so choice modeling to assess consumer preferences. So a choice experiment will be embedded in the web survey. And basically what it boils down to is that we present stakeholders, consumers, general public, with a series of forest management alternative, different wood products, and some characteristics, and we ask them which they prefer. Again, we cannot do it for all products, so we have to focus on a selection of wood products. So far, we have been discussing it already. On the one hand, you could think of building materials, though consumers are not buying those on a regular basis. It's only once or twice when you're building a house. So therefore, we might think of looking to some furniture, for example, things that consumers are buying more frequently. So we present them with different wood products, ask them whether they are willing to buy it for a certain price, and those wood products are then described based on certain characteristics. We will also investigate we ask them for their preferences. If we then next provide them some extra information on the forest management behind those products and how sustainable that is, we can investigate to what extent by providing information or maybe through ecological carbon label, we can stimulate consumers' willingness to buy and also pay for those long-lived wood products. Then, next slide, please. So forest management delivers certain wood products, but it also delivers ecosystem service and biodiversity. We believe it's important that the alternatives that are proposed that are community supported. So we will also, in a limited set of countries, assess consumer preferences for the management alternatives and their related ecosystem services and biodiversity. Also there, we will rely on a web survey with a choice experiment embedded in it, and we present the participants in that survey with different forest management scenarios and the characteristics and the ecosystem services linked to those scenarios, and we present them two by two and each time ask to what extent they prefer one over the other. And again, we will investigate to what extent by information provision we could alter their preferences. Then, next slide, please. Fourth, if we propose alternative management scenarios, of course, it are the forest managers that have to adopt those alternatives, and hence we also need to make sure that they see it possible, that they are supportive of the proposed scenarios. Therefore, we assess forest managers' preferences for the adoption of management alternatives. We will do some qualitative interviews with forest managers and owners to map hurdles and stimuli that can affect their decision to adapt new management practices. And those data will then be analyzed to compare decision-making among different types of forest owners, managers, with different objectives, knowledge, experience, and so on. And then finally, fifth, we will bring all that information together to assess the feasibility of a payment for ecosystem services. So if forest owners or managers adopt a certain management alternative, they might forgo some income. So this means they might need to get some compensation to adopt those management alternatives. We will look into that, to what extent there's a need to compensate them to adopt certain scenarios. The upper boundary of the compensation is then determined by the citizens' valuation of the ecosystem services that are provided under certain forest management alternatives. Bringing all those information then together allows us to assess whether there's, or to explore whether there's a potential of an instrument like a payment for ecosystem schemes to stimulate the adoption of forest management alternatives that have a high carbon mitigation potential. And yeah, these are some key activities that will be performed within this project to assess whether forest management and wood products can contribute to a sustainable bioeconomy. So with that, I would like to pass the floor to Sven Solberg.
Yes, hello, my name is Svein Solberg and I am leading the work package number 5. And in this work package, we will identify forest management options for forests in Europe with attention to two important things. One is the trade-off or the balance between different ecosystem services. And the second is to consider resilience against climatic stress. So take the next slide, please. So what we do this year is that we spend most of the time, I would say, outdoors in the forests around Europe. We are traveling around Europe, visiting certain forest types, and we are then discussing forest management options in the field. So partly in groups, as you can see here, because we have stakeholder categories, 5 groups altogether. And also we have plenary sessions where we discuss also. What are we discussing? I mean, if we can start, let's say, with a simple question. What tree species should we use in Europe in the coming years? Should we use, for example, spruce, like you see here? Or should we replace the spruce with oak, for example? Or should we in general switch from conifers to broadleaf trees? And perhaps you believe that we should, in general, stop using spruce and start using broadleaf trees. Firstly, because spruce is largely introduced in large parts of Europe, and it typically forms like even-aged monocultures. They are not very nice for recreation, maybe. They are so dark that there is little ground vegetation, so the biodiversity can be low. And if you take the next slide, please. And also we have seen in Europe the last years enormous areas of dead spruce forests because of drought and bark beetles. So perhaps the answer to my initial questions should be evident that we should definitely replace spruce or conifers by broadleaves like oak, but it's not that easy. So firstly, if you go to the Nordic countries like Finland, Sweden and Norway, spruce and pine are the natural tree species. They're not introduced here. So if we change from those conifer species into broadleaves, that means a big change in the landscape in our countries. Secondly, if we compare these two species as I introduced you with, spruce and oak, we know that spruce forest can take up twice as much carbon from the atmosphere as an oak forest. So spruce is twice as effective as oak and most broadleaf tree species in mitigating climate change. Thirdly, the oak trees are very popular among deer and moose, for example. They are heavily browsed. So if we want to raise, let's say, oak forests at the expense of spruce, we will need to fence large forest areas to avoid browsing, which will be quite expensive. And also, if you compare those tree species, spruce has another advantage. You can grow an old and mature spruce forest in as little as 40 years. It's a quite short rotation. While if we plant an oak forest, we would need 150 years. And let's say the risk for climate disturbance in forests is always there. And the longer the rotation time is, the higher is the risk that we get a complete breakdown of a forest because of some climatic disturbance. So spruce has the advantage of a higher turnover or quicker rotation age. And finally, the forest owners, they earn more money on spruce, and the forest industry, they prefer spruce and pine. So it's not so easy for the forest owners to make money on broadleaves in general, and the forest industry is not so interested in that. And as you know, we also should, in a climate change setting, try to let's say, replace steel and concrete in buildings, for example, by wood. So having a high wood productivity is also important, and that favors the coniferous trees and spruce and pine. So take the next image, please. Yeah. So the answer is really tricky to find out what is the best option for forest management in Europe. And just to show you, this is from a very dense spruce stand. So in this case, we have 800 cubic meters per hectare of high quality spruce. So this is a planted monoculture. However, as you can see, there is some green in the bottom here. It's quite nice to walk here. It's very cooling atmosphere in a warm day. And in this case, we also saw a goose hawk nest in this forest. So there is some biodiversity, there is some recreational value, even in a monoculture, even-aged spruce stand. So the question is not so easy to find the best forest management options. And altogether, the important thing for us in this work package is to bring together, as you can see here, stakeholders from different categories: forest owners, forest industry, biodiversity, forest recreation, and also forest officers representing the governments, to have the different views and the different preferences for forest management, and trying to combine that into, let's say, good options for future management of our forests. And yeah, I think I just stop there. Thank you. And I give the floor to the next speaker.
Could you move the slide on? Thanks very much. So we've heard a lot about the analysis based on empiricism of forest systems right across Europe. But of course, we're also interested in trying to explore the future as well. What is the future of forest systems? And to do that, of course, we can't observe the future, so we need a whole set of different methods to explore how the future may unfold. And that's what this component of the Climate Forest is about. It's about integrated modelling of forest land use and management in order to understand the impacts of alternative future scenarios and to inform policy and policy pathways. Next slide, please. So the critical research questions that we are planning to address are primarily how will forest land uses and how will the management of those forests change in the future across Europe. And in particular also, what will these changes in forest systems, what are the implications of these changes in terms of their impact on the broader environment? And that involves, for example, changes in carbon stocks and relationships to the regional climate, as well as the global climate. It means impacts on broader ecosystems and biodiversity. It might be impacts on water cycling, for example. But also we're interested in trying to explore how different policy interventions can influence the future directions of how the forest sector evolves going forward in terms of use and management. And of course, one of the critical questions that is always important to address within this broader context is how could we reconcile the challenges for climate change mitigation, primarily through carbon sequestration within future forests, but also reconcile that with the need to conserve biodiversity and halt the loss of biodiversity across Europe. So overall, we aim within Climb Forest to integrate a range of advanced computer models that will allow us to simulate future changes in European forests for a range of alternative scenarios that capture both changes in the future in the socioeconomic baselines, but also address questions related to climate change. And the next slide, please. And that computer framework broadly looks like this. So if you look at the central component, we have a model looking at supranational land use decision-making and decisions around management called the crafting model. Talk more about that in a moment, which links also into international trade models known as the Plum model to account for the fact that Europe isn't in isolation, that it's trading with the rest of the world, and we have to account for land-based commodity inflows and outflows. But we're also, a part of that, looking at the human system, interested in the institutions that are responsible for public policy. And so we're going to explore how we can model endogenously policy decisions as part of the broader forest land system. But importantly, related to that are a whole range of models that allow us to explore biophysical changes in forest systems, primarily looking at changes in plant growth, but also biogeochemical cycles through the LPJ guest model, and links between LPJ guests and the regional climate through the RCA guest model. And we're also, most importantly, looking at the impacts on biodiversity through a model called Trait SDM, which looks at species distributions and consequences for biodiversity of changes in the land system itself. Next slide, please. So at this point, I'll hand you over to Paul Miller, who's going to talk to you a little bit more about the LPJ guest model.
Yes, good morning, everyone. So our tool for modelling the European forest ecosystems, both up to present day and into the future, is known as LPJ guest, the Lund Potsdamiana General Ecosystem Simulator. And it's a process-based second generation dynamic vegetation model where we aim to simulate the forest composition and structure dynamically through time, from historical periods up to present day, and then from present day into the future following various scenarios that Mark just mentioned. So it's process-based. It takes as input carbon dioxide, nitrogen deposition inputs, and also the climate history and future scenarios. And also, of course, the land use and management scenarios that we wish to explore that will come from the LandSim setup. So we simulate processes such as primary production and growth, plant geography, soil biogeochemistry, and population dynamics and disturbance. And what they do is they combine to update dynamically the state of the forest in terms of its forest composition and its structure, and also the pools of carbon, nitrogen, water geographically around Europe, but also the fluxes of water, carbon dioxide, nitrous oxide, and BVOCs that were mentioned earlier. So we do this at a very detailed, individual-based level. And what we're doing currently at the moment in the lead up to the full simulations for the entirety of Europe is that we're updating the model. So we're finalizing the main forestry and management functionality. There's a slide on that in the next slide. I'll come to that and I'll show you an example. We're improving the representation of the European tree species, which we'll be modeling. We're implementing the stand initialization functionality. So in other words, to try to generate this present state of European forests as informed by the other work packages that you heard earlier in terms of age classes and the type of species that exist where. And then, of course, we're using our colleagues' work, including, for example, NFI stem density, biomass growth rate data, and remote sense data to update and calibrate the model parameters to get a better representation of the present day functionality. And we're also then, of course, further calibrating and evaluating the model using the data such as forest harvest rates, the data coming from ICOS, the fluxes, the remote sensing, etc. And also, of course, as we heard earlier, as we heard from Svein, we also expect our forests to be experiencing increased levels of disturbance in the future. And that comes from wildfires, storm damage, and bark beetles, for example. So we're implementing that functionality in the model as well, so that we can explore the impacts of those disturbances in the future and how best to avoid them, and the resilience question. So we're selecting various climate scenarios from Europe, and we'll be using those then to project forward in time for multiple climate scenarios and also the land use scenarios that we'll arrive at in this project. So next slide, please. So just as an example, could you just click once again, James, please? So there's various, what functionality exists in the model. So we have various, the facility to simulate various management systems, such as uneven age forestry and even days forestry. And then within those systems, we have various management options, such as planting of specific tree species at a certain densities, re-establishment, thinnings, rotation times can be varied, clear cuts can be implemented or not, and we can select species cutting, and then of course we have fertilization of nitrogen and maybe irrigation as well, and maybe even fire suppression and different types of management change. So we can implement those and explore the effect of those management options on the ecosystem service that we're interested in. So next, just as an example then, as just an example of the type of simulation, that the output that we get from an example from a paper by Mats Lindeskog. So for a site in south of Sweden, so here we just have implemented, so if you just look at the bottom figure here, the time series, so we have a natural forest, and in 1900, we plant a spruce monoculture, and then we thin it automatically through the years until the year 2012, and then we clear cut it and plant a mixed broadleaf forest, and then there's implementation of automated thinning as well in the future, and then a clear cut at a later date. So what we're showing here, a graph, is vegetation carbon, and we can see how that changes over time. And in the top time series, we can see the harvested carbon over this time period as well in response to those thinnings and those clear cuts. So that's the type of thing we can simulate in the model, not just for one point, but for the entirety of Europe. Next slide, please. And then to capture the feedbacks, of course, this is an offline model. In its standard guise, LPGS takes as input of climate and produces simulates the dynamic state of the ecosystems. But of course, we expect feedbacks to occur as land use changes, as forest management changes, and as the fluxes change. So what we will do then is we will couple together this model, LPGS, with a regional climate model, which normally in their standard guise just use static inputs of land surface characteristics. So we will put this output of dynamic land use change and vegetation change in as the boundary condition for the regional climate model, set up for simulate for a European domain. So that will include, for example, the leaf area index, the type of vegetation that occurs where, for example. And then next click it one more time, James. And then it would produce weather and climate. And of course, then it will be fed in, and that will be used in turn to feed into the LPGS model. So the LPGS model will respond to the simulated climate, and the climate will respond to the simulated vegetation. So in turn, so you get a closed loop for the biogeophysical feedbacks that we expect in these scenarios. So this model setup is known as RCA GES. So we'll be running that as well, maybe in a year or two. Next slide, please.
Thanks, Paul. I'll take over again. Right, so we've heard something from Paul about the biophysical modelling, but of course central to understanding how forest systems will evolve into the future is around the decisions made by individual forest owners and forest managers. And in order to evaluate those types of responses to future scenario changes in the socioeconomic baseline or the climate baseline, we'll be modelling with an agent-based model called Crafty, which is a pan-European model. So we're going to be doing wall-to-wall analysis of changes in land use and management within the forest system for every European country, plus some additional countries outside of the European Union. The idea of this model is we want to model, we want to focus on the behaviours of individual land users and land managers that underpins the decision-making of those individual land users. But we also, as part of that modelled analysis, look at the interactions between individuals within broader societies and communities. We're looking at issues around, for example, the exchange of knowledge and information between individuals and how that can influence the propagation of knowledge and thought around how management should evolve in response to changing conditions in the future. We also have a keen interest in trying to understand and evaluate pathways to achieve policy goals, which are both current policy goals related to forest systems. For example, the EU biodiversity strategy of planting 3 billion new trees by the year 2030 would be one example, but also in trying to understand the emergence of future policy goals and the types of pathways that might be possible to achieve those goals. And to do that, we're building a novel representation of public policy institutions within the Crafty model itself. So we're effectively endogenizing the policy-making process within our models, which will allow us to then couple the policy process with the responses of individual land managers on the ground. So that's quite a novel approach to trying to model these policy pathways to these future goals. Okay, next slide, please. And that's all from the modelling group at this moment in time, and I'll hand you back to Adam.
Yes, thank you, Mark and Paul. We can go to the next slide. Yes, so we don't just want to do this for the sake of research, we also want to influence our stakeholders and the rest of the society to instigate some changes in the forestry over entire Europe. So we are hoping to influence the foresters and forest owners to make climate smart choices and resilient choices for the forest management in the Climb Forest project, and that these stakeholders should influence other stakeholders in turn outside the project. So it will influence a whole lot of people in Europe. We want to influence how wood products, long-lived wood products are used, and also influence the policy-making process in Europe to consider all the factors for a climate smart and resilient forestry, both on a national level and on an EU level. And we also want to reach other researchers with the research that we do in Climb Forest, but also to collaborate with other projects that are looking at the forestry in Europe and how we communicate our results towards the outer world. And we also want to influence and educate the entire society in this with the sustainable forestry. Yes, next slide, please. And how can you get involved in the project? Well, you can draw upon on the networks that we have in the project and meet other stakeholders and researchers in the project. You have an opportunity to discuss forestry with our stakeholders in this project. And also, of course, you're welcome to contact all the researchers taking part in the project. Somewhere into the project, we have several products that will be available for other researchers and people to look at. For example, we will have an interactive map where you can click on different regions in Europe and see if you plant a certain type of forest, how it will it function for climate and other ecosystem services. Does it perform well? Does it give revenue and all the other things that are connected to this forest? And of course, please take part also in the policymaking process, where we're hoping to reach the policymakers through workshops and producing material for policymakers and so on. So there are different ways to engage with our project. And next slide, please. And you can contact us. We have my email here given here, but also to Paul, who was speaking just recently, who is the deputy coordinator. And you can, of course, also contact all the other researchers that we have met today, who have been talking today. Please contact them directly if you have other questions or want to get involved. You can also get involved by looking at our newsletter, follow us on LinkedIn, Twitter, and visit our website. And this whole webinar will be available as a recording afterwards. So please have a look again if you don't remember everything that was said today. And yes, and with this, I finish this webinar. And please, stay in touch with us. And thank you for listening today. Thank you very much for this.